of New England's solution seminars. My name is Russ Muller. I'm Area Technology Manager with the Rosemount Measurement Business Unit of Emerson Process Management. Today's topic is Purely Digital, the Future of Automation. And for those of you who may join late, there will be the very last slide of this presentation will give my contact data, and so we can make these slides available to anyone who missed, who wants to catch up, and of course who wants to call and follow up, and then we can arrange personal visits or whatever helps your business best. So without any more, let's get into it. That's me. Here is essentially the agenda. What first we're going to do is make the business case for why purely digital, or why we're talking about this. Then which protocols would you use? Comparison among the best. And what I mean by that is that this will be something that I repeat many times throughout this presentation. Today's current automation and instrumentation architectures are pretty uniform. Put a bunch of devices out, pull a bunch of wire, all back to a central point, and every measurement point, every final control element, every node is on a separate twisted pair. That has worked well for decades, as we know, but we're going to, purpose of this presentation is to sort of show where the future is going and why it's going that way. So that's why we're talking about multiple protocols. Now, and then, of course, if you're going to talk about them, how are you going to prepare for them? What about the control host? Everybody that's listening has a control host of one sort or another. And I'm not going to sit here and tell you that you got to change. What I want to emphasize, however, is the control host's part in this. And then finally, we're going to do some future developments. So, why is the slide not flipping? Okay, good. There we are. Okay, so the business case. If I were to the first thing that everybody did with bus technology, particularly, which is what going to be a major part of what we're talking about going forward, is they looked at lower project cost, and that is certainly a driver, and it is why it's the best. That's why it's the top bullet point on the slide. It's the first thing everybody looks at. You're executing your project. You want to get you want to essentially accomplish the mission for the most effective cost. But purely digital will show you that infrastructure goes down, install cost goes down, change orders, things that when you change your mind in the middle, that cost is reduced. But the main benefit, the reasons why people are going purely digital are the following bullet points: higher process availability and reliability. The digital protocols were invented essentially for that sub-bullet: eliminate on-scale and unenunciated failures. A digital architecture does not allow you to do that, so you can't take action on bad information. Your maintenance cost is reduced, because once you have everything coming back to a central point, and the intelligence is coming back to a central point, not just the process variable data, you get a faster response possibility built into your architecture, so that when you do have an upset or you do have a question, you can get to the resolution of the problem much quicker. And then finally, the maximum amount of information. Digital automation, digital instrumentation, digital architecture does not allow you to not have the information. If the system is up, you're having all of the information that is available presented right in front of you. So now it gives you the chance to instead of being rocked back on your heels throughout the workday, you can start to get proactive and start to anticipate what you have to do. Interesting. Okay, so finally, let's get into costs for the beginning of this. Wiring costs, and back in the day, the early days of the digital buses, particularly, that was the #1 selling point. We're going to reduce your wiring costs. So, is that really true? Well, here is a 12-pair shielded twisted pair, going for $1,600 for a 500-foot coil. That's, I guess, that looks fairly reasonable. And then, however, a shielded multiple pair cable, for as you would use for a bus, is looking all of a sudden a lot better, right? A 250-foot coil for $236. So what we're seeing is that there really is a savings in using a bus just from the wire. Let's take a look at the rest of it. So I'll build this slide. In a conventional implementation, there are the costs compared versus a field bus instrumentation. Now notice I am not differentiating. When I say field bus, I mean one of the major field buses, Foundation or Profi. This would be applicable to either one of those, where your wiring cost has gone down. But the main thing is that your labor afterwards goes down as well. So your the number of terminations, when you think about what the total number of terminations is on an entire project, you can see where that price is going to have an impact on the project. Okay, so now you may have heard, somebody may have said that the field buses are slow for some reason, and in some ways they are. In a control host that is executing control in the controller, if you have a Foundation field bus, you have a separate macrocycle on the bus, and that can be that is a second cycle. So that can be if you don't do a good design. However, if you use Foundation field bus to its full potential, it is the fastest way to do control. And as we say here, with unequal determinism, you cannot not have anything. You can't have anything unknown. So, and here's where we begin to fill that piece of data in. If you design your segments correctly, you can run very, very fast. And in fact, we can show in a control in the field application, that's the fastest way to use Foundation field bus, I can not only operate very, very close to set point, but I can have shorter response times. I can run closer to, my running closer to set point gives me a lot of benefits. Many systems run best when they're running right at the edge of their performance envelope, and so a bus that can essentially run itself enables you to get there. That's what people discover when they do control in the field. This is actually a result of a study that was done by setting up a control loop with a deliberate perturbance in it. So we had a control valve and a pressure sensor, and in this particular case the pressure sensor could update 100 times a second. So this was done for research purposes, and the purpose of this presentation was really to show what I was talking before. If you are doing control in the host, in this case control in Delta V, you see where my arrow is running. My control in Delta V is slower, my response is slower than control in either on the segment, that's what the control in the field, CIF, or analog control. You can see that I'm a little slower up here when control is done in the host. In fact, this study was done for how much oversampling of macrocycle does the controller have to do, and what is the impact of that. So, but inadvertently, what they showed was that control in the field is as fast as the fastest way they could do analog. The point of this slide is really this underline, not a religious experience. I am not, this presentation is not a point of view for a particular protocol. It is really a distillation of what I have found going across the country, and a little bit of background which may explain that. For 5 years, Rosemount had me traveling throughout North America talking about digital data bus and how to do it and doing training and things like that. And when I found people who were doing mixed protocols, mixed digital protocols, and why did you make the choices that you made? This presentation is really a distillation of that, and in fact we're going to have at the end of this presentation a use case where I actually interviewed the project manager and say, why did you make the choices that you made, and what were the lessons that you learned? However, having said that, it is not my purpose to proselytize. It is to present the best choices as a result of what I have found. So, coming back to here, there are many, many choices you can make. You're going to select the best fit for your needs. If you don't need a feature, there is no benefit. If you have multiple choices to do things, you're going to pick the one based on selection criteria, which we're going to get to right now. And there are a couple of slides on this. The first consideration is the type of I/O you're dealing with. If we were talking, by the way, about manufacturing floor automation, factory automation, this presentation would be different than it is now. We are really talking about process automation. These are the markets that Emerson serves. And in the process industries, you do have a mix of discrete and analog, so you're balancing those discretes, those analogs. You're not really talking about motion control, fast fill and finish. We're not going to discuss that. As I say, your choices would be different. What percentage of your points are smart versus dumb? Increasing, you will start to see that there is an effort by manufacturers to add intelligence into the devices that they're making. There's even some smart discrete coming up, which we'll show you a logo for, but we're not really going to talk about. What percent of the I/O is control versus safety? Safety is a subset and has to be treated slightly differently. The functionality needed. Do I just want the I/O? Do I want to start having a conversation over the back with my instrumentation? I would argue that you do want to. Do I want to bus power my instruments, or am I going to locally power all my instruments? That will have an implication in the slide coming up. Do you have any existing bus field devices? If you're in the sub-bullet here, if you have suppliers that you favor, what protocols do they support, and what choices do they offer? If you are dealing with one vendor that has a lot of choices versus another that doesn't have that many, that may influence your decision. How large is the site? Your choices are going to be different if your runs are going to be 1,000 meters versus 100 meters. Hazardous area. Do I have to consider hazardous area classifications? Do I have to have a high availability? Is it favorable for me to be able to build in redundancy? What diagnostic requirements am I willing to consider and deal with? I would argue that you're going to want to take a hard look at diagnostics from the standpoint of availability versus the issue of having to set up and train people and interpret and all that sort of thing. One of the things that you will see in an upcoming slide is that manufacturers are working very, very hard at getting increased complexity to have a an increasingly simpler interface. My synchronized communication consideration. Motion control would be probably even a faster response than a PID loop. Intelligent device management, these two, EDDL, FDTD, those are sort of acronyms that are kind of a deep dive. You may, if you're paying attention to those right now, we'll get a little bit into that. Increasingly, the difference between them is going away. Training is an issue. Diagnostics, once again, I'm going to want to, as much as I can, but I want it intelligently presented and used. My selection criteria has to include how do the various different protocol organizations support the protocol that I'm thinking about using. Do I want to use one that has a lot of support from a lot of manufacturers, or do I want to use a proprietary? That's a choice that you make. If most people will not want to stick with a proprietary unless that vendor gives them very, very good support. So which protocols would you use? Once again, this presentation is a distillation of things that I have learned from various manufacturing facilities in various industries across the country. And the distillation is really on this slide. You're going to use more than one. Like I said at the beginning of this, 4 to 20 is sort of a flat, everything is the same, bunch of devices, pull a bunch of wire, and wire it up. When you start using digital protocols, you're going to use more than one. That choice will be influenced by legacy infrastructure. If you do have a large infrastructure, it's going to influence which ones you use. But within that constraint, I would suggest that for continuous and control and monitoring applications, your first choice is going to be Foundation Fieldbus. Notice that I have an asterisk there that says you could also use Profibus PA if you accept the limitations. We're going to talk about the limitations. For continuous control and monitoring of analog values, Foundation Fieldbus is unequaled. For drive control, Profibus DP is unequaled. There are others. We'll show you others as well. For remote, wireless HART is growing fast. It's coming on strong. For safety systems, what we're seeing is that the best technical choice actually is, for now, until bus safety starts to be an industry standard, the best choice right now is to use 4 to 20 milliamp with HART instrumentation and to apply HART adapters to the critical instruments so that you can have the continuous conversation with your safety instruments, do things like partial stroke testing of your emergency shutdown valves while they're in operation, and put as little impact into the overall system design as possible. And there is technical proof that not building the asset management into the safety system, but adding it on through wireless HART is actually a better technical solution. That's once again a subject. That's almost a subject for a separate presentation on its own. For discrete, you have multiple choices, and we're going to talk about a little bit about all of them. We've got our friend Profibus DP there, OSI, which many of you are familiar with, and of course for our friends out there who have Rockwell Automation and its related partners, DeviceNet is certainly a good choice, and you're going to see why the business case at the end of this presentation chose DeviceNet actually. So why Foundation Fieldbus for control of and monitoring? First off, it is the only automation architecture that was designed to be a control system on a bus. The devices can do control without needing a controller external. That's why the loops run so fast. That's why the high determinism. That's why the low variability. Better process control. I have fewer components in the loop. Everything runs faster. That's why my process control works better. My process variables can be more accurate. They are always going to be more accurate because the number of conversions is down. Once again, this is a subject for another day, but in a smart instrument, there are a number of analog to digital, digital to analog conversions, each of which takes a little bit away from the accuracy. In pure digital, there's only one conversion, so I get those tolerances back. I can scale with size. I can just add. It's very, very easy to add to a Foundation Fieldbus infrastructure because I've already added my infrastructure once I've put the first point out there. Most critical, never take action on bad information. The very first digital protocol, which was Honeywell DE, and I always took my hat in their direction, that was the #1 benefit that you got from DE. The host knew that the device was good. It knew that what it's getting was within the device's capability to understand itself good. It could not take action on bad information. And that has continued and gotten more robust as the protocols have increased. More process information available. Digital devices are all multivariable devices, so that installing a point gets me much, much more data in a digital architecture. The fallback control capability, I can, in Foundation Fieldbus, have a backup controller on each segment if I wish, or even if I don't wish. The system sets itself up to do that. It is open. It is interoperable. Once again, subject for deeper consideration on another time, but the standards bodies are enforcing that open nature. Why did I suggest? Why the asterisk of Foundation Fieldbus over Profibus PA? The function block linking is the #1. The fact that blocks can be linked together allows for the control application. That's this faster control with higher reliability. However, there's more to it than that. I have the ability to put remote indicators out in the field so that a device that is inaccessible can be viewed from a remote point. Temperature multiplexers, we do have devices available that have 8 measurements in one device instead of 8 installed. For low to medium density discrete areas, I do have DI and DO multiplexers available. So now I can reduce my architecture. I don't necessarily have to have a discrete bus and an analog bus. I can do everything on one bus if I wish, depending on the circumstance. And then finally, I'll skip this one because I talked about it. I'll talk it to death. Multiple devices can be used to solve tricky applications. Sequential electronic remote sensors. So if I had a distillation column 150 feet tall, I could measure small differences up and down the column on a single wire with single devices talking to each other and working out the differences. Or I can do compensation. I can use multiple instruments to arrive at a complex measurement solution, and that really can only be done when the devices can talk to each other. Yes, you can do this in the controller. Yes, you can bring everything back. Yes, you can let the controller do the calculations. You can do all of this in the host. However, the host controller load and idle time gets to be consideration. If any of you out there have had, gee, we have to either update our DCS or we have to start adding PLCs because our DCS is maxed out. Buses make that go away, or they push that decision point far off into the future. And then finally, availability of more advanced diagnostics. This is something that any end user can determine for themselves by talking to various vendors, looking on vendor websites, looking at the availability of advanced diagnostics, and having that conversation. But you will find that in Foundation Fieldbus there are more diagnostics available than there are in any other digital protocol. However, they're not that far different, right? Foundation Fieldbus use the same physical layer. It's the same IEC specification. the same communication speeds, the same wiring length and restrictions and statistics for the wiring, the same number of nodes. Both Profibus PA and Foundation Fieldbus carry signal and power on the same conductor. Profibus DP does not, but Profibus PA does for field instruments. Profibus DP is not generally used for field instruments. There are some. Both transmit PV and statuses. The differences, however, will be highlighted when we start talking about Foundation Fieldbus. Both can be, you can do offline configuration for both. You'll see that it's easier in Foundation Fieldbus. The backup link active scheduler, that's what LAScape means. That's the backup controller. Exists only in Foundation Fieldbus. The deterministic communication, Foundation Fieldbus has a time signature on the conductor. Profibus PA does not. The devices can talk to each other. Scheduled and unscheduled communications are allowed. There's room for it. There is in Profibus PA, but it takes longer. And broad device availability in process devices. If I were to do a comparison of the two of these, as far as Foundation Fieldbus, we'll get to Profibus PA in a minute. The simplicity, you see that on yellow. It's not as simple as 4 to 20 milliamp. However, the device offering is green. It's very, very high availability device types. Configuration tools, there are lots of them, including handhelds. Safety, that's red because nobody is doing safety on a bus yet. It has been proven and it works, but no one has bought serial number 1 yet. Diagnostics, unparalleled. Active communication, unparalleled. DD compatibility, you see that's red. That's over time you'll see that will start to turn to yellow. That has been a problem in Foundation Fieldbus. You have to pay attention to your device drivers more than you ever did in 4 to 20, certainly. But you also have somewhat the same issue in Profibus PA. We'll show the difference. Control in the field, it's green. Only Foundation Fieldbus can do that. Multivariable, that's, once again, I said that once you have a bus instrument, everything the device can measure is sent to you. No wireless availability, high technical knowledge. It takes a little bit of training, a little bit more training to do this and work with it than 4 to 20 milliamp, but the required infrastructure cost is low. So now take a look at Profibus. Profibus PA, actually the first bullet point really refers to Profibus without any qualifier at the end of it. Profibus was developed to be a single protocol for an entire plant. And when you remember that Profibus was designed for manufacturing, it was not designed for the process industry. In fact, process automation came along years after Profibus DP was developed for manufacturing facility. I can have a single protocol for the entire plant. However, to use instrumentation, so here's my DP side. My DP side connects directly. Everything connects directly to the DP side, but my instruments have to go through a bridging device. So here is where I have to use a bridging device to get automation onto the DP bus. Control is always in the host. Control is not allowed in the field device. It is Profibus PA is a master-slave protocol. The devices are slaves. They sit and they wait for the control to come out and ask them things. They initiate no communication on their own, and we have to go through bridges. So we have right away start to have more components in this architecture than we do in Foundation Fieldbuses. However, one of the things that Profibus, both the Profibus without qualifiers at the end, without the PA and DP, and process automation bring is the concept of a profile. Every device has a profile that once the host understands what that device type is. The device just works when it's hooked up. That's the beauty of profiles. It's a very, it makes implementation of Profibus PA, it can be simpler, and we're going to reflect that. Simplicity, I'm still yellow because I have some training. This is a digital data bus. My device offering is where this was green in Foundation Fieldbus is yellow here. There just are not as many Profibus PA process automation devices available. Configuration tools, they are limited. One of the things that you will find, if anybody out there has a 275, 375, 475 field communicator, there is no such thing in the Profibus PA world. You must do all of your asset management through a fixed platform. I'm still red for SIS because there's no bust safety in Profibus either. That is commercially, it's commercially available, but nobody's bought one. Diagnostics are very good. Active communication, there is none. It's master-slave. DD compatibility, the concept of profiles makes that easier if you just want to use the field devices as PV generators. The DD compatibility is not that much of an issue if you just, until you start to get to use asset management and diagnostics. Control in the field is not possible. Multivariables are possible. Wireless availability is not. In fact, all of the buses have announced that they are going to be integrating with wireless HART. Technical knowledge is not quite as high as with Foundation Fieldbus, but it's not all that much difference actually when you take a look, but the required infrastructure cost is lower. So let's flip the slide. Let's compare all of them. Now, we didn't do HART and analog before, but this is a sort of a comparison across. If you take a look, and I said this before, analog and HART, they're simpler. They're simpler than the buses. The device offering, however, the greatest device offering occurs as the protocols, the older protocols have more devices available. Profibus PA just has not developed. In the world of Profibus, process automation is not as important as it is in the world of Foundation to processing industries. SIS is still the province of analog devices. HART implementation in SIS requires some work, and there is impact on the function. There is none available. Nobody has bought it in Foundation Fieldbus. The diagnostics, however, there are none in analog, but there are plenty in the buses. We've seen these comparisons before. We're not going to spend much more time on this slide. Okay, things you need to do. You're going to see this repeated. Get training. It's different from analog, and the things that you don't know can hurt you. However, one strategy is if you're going to try implementing this, give it to a new crew so they don't have bad habits that they have to unlearn. They don't have to fight with what they know already. And actually the natural progression of the workforce in this country, and since none of you can see me, you can't see my gray hair, you can't see my Medicare card. I am closer to the end of my working career than most people listening, but I can tell you that as this generation changes, and I'll be around for another few years, the new folks coming in are going to naturally gravitate to this stuff. There is a work process change. Once you start putting in digital instrumentation that has, especially in Foundation Fieldbus where there are control functions, who does what is going to change. However, everybody likes this bullet point, stopping the manual checks. The bus talks to you. And in fact, we can show multiple ways where you can, a person who has to do troubleshooting can get their information within minutes of the upset having occurred. And making a lot of that manual check go away is a big benefit. The technology should serve you, and so take a look at these and look at the tools available and see if demand the tools that work the way you do, and work it out in that order. The diagnostic capability in SIS, you want as much of that as possible. SIS, as you know, is required not very often, but when it's needed, it is required right now, on demand, without fail. To have diagnostics built into the system so that you can make sure that when you absolutely need it, it will be there, is critical. You can see where that would make sense. Adding wireless heart, there is actually an Exida FMEDA report on the wireless heart adapter showing that it has no effect on the safety loop, but it does give you the visibility, right? So we're not affecting the system, but we are giving ourselves the visibility. So that adding wireless heart to a safety instrumented system is actually the most efficient way to do it. And then finally, if I'm using my diagnostics, I can start to make my proven in use case should I need to do that. Discrete's your choice. Profibus DP, because of the protocol was developed in the mid-80s in Europe, you will find that there are more node types available in Profibus DP than there are in any other protocol. And that is because it was developed for factory floor automation, so there are things that only DP does, like motion control. That's a big one. Fast fill finish. Running robots and things like that on automobile assembly lines. That's all. So there are lots and lots of DP nodes available. The speeds that are available, if I'm within that 100 meters limitation on the fastest speed on DP, I can go 12 megabits per second. Very, very fast. You can see how that would work well on a fast fill finish or manufacturing line. You can adapt just about anything to Profibus through protocol converters or couplers. They're available for everything. OSSI short distance, but very, very economical for high density. If you have a high density discretes, OSSI is a very popular, very economical way to do it. Very effective for batch operations. DeviceNet is very, very popular because of the strong Rockwell Automation and its partners base, particularly in North America. Huge installed base, lots and lots of support. You'll find that most manufacturers make DeviceNet devices for that reason, and DeviceNet can do more than just discretes. It is capable of motor control, power monitoring, etc. So that is going to become a popular choice. You'll see why the use case we go through later chose it. Ethernet devices are starting. We get increasing questions about them, and they fall into two general flavors. Ethernet IP, which is it's an open standard which is supported by ODVA. We have the link to their website at the end. There are lots and lots of Ethernet IP communications possibilities, but field devices, if they land, for the host that they land on directly, so if I have an Ethernet IP or a Profinet and I have a device that can land directly on it, boy, it's fast, because Ethernet IP or Profinet can run at 100 megabits per second. It's very, very fast. It can be. But I am restricted to short distances. Once again, if you look at the Ethernet standard, Profinet standard, my fastest speeds are limited up to 100 meters, unless I start using fiber, which brings in its own set of concerns. 4-wire devices all work very, very well in Ethernet or Profinet, because you cannot carry power over the Ethernet at this point. So if I have an independently powered device and I just put it on a net connection, and I don't require intrinsic safety, that might be a good application. If I had skilled installers and maintainers, particularly if I'm going to start using fiber, no problem. This bullet point here, where automation and instrumentation, it's almost a kind of a tongue-in-cheek bullet point where everybody gets along famously, no problem. Why is that tongue-in-cheek? Once you start having a net-based device, who's responsible for it? Instrumentation group or IT group? That's a discussion that you have to have internal. For complex devices that have a lot to say, like a Coriolis meter or gas chromatograph, absolutely second to none. These are 4-wire devices. They have a ton of information. They have lots and lots of variables, lots of information. Ethernet or Profinet would be a wonderful solution. One of the things that you may realize is that most automation vendors do have some Ethernet ability built into their system already. Their various remote marshalling panels and things are using an Ethernet backbone, so it's built in already. We will show you where this is headed as far as proxies instead of couplers and links in a little bit. Okay, wireless HART, we sort of left this toward the latter part of this discussion. We're calling it the new generalist. It's kind of for measuring the unmeasurable, for doing things that you could never do before. We can't make a measurement there because we can't get wires there. We can't make a measurement there because the thing is rotating, it's moving. We can't wire it. So that's what wireless HART is for. It's too expensive to trench. Tank farms are famous for this. Tank farms are a sweet spot for wireless. What if I think of something late? You know, gee, I wish we had a point out there. If I've got a wireless HART infrastructure, it's just as easy as just making the decision to go out and add the point, buying the instrument, mounting it out there, putting in the power module, and it's join credentials and walking away from it. It's that easy to do. And the other mitigations that we can. Wireless makes things possible that were never possible before. That's why it's the new generalist. Things you need to do, it's okay to get in now. Some of you may be aware that there are 2 competing technologies. One of them is clearly dominant and is clearly preferred. Take a look at everything, see how it fits in your architecture, but you'll see that the benefits are there. The node types are growing daily. But get training. It's not as hard as you may think, and cut through the stories. Once again, be open to adjusting your work practices. You're not going to be doing as much walking. With digital, wireless is the bus without wires. With any digital protocol, the information comes to you without having to ask for it. And then the technology-intensive site surveys, line of sight, not as critical anymore. With wireless HART, most installations go in without any need to do any kind of RF spectrum analysis at all. In unusual situations where we have a bad RF neighbor, somebody put in an RF infrastructure and they didn't bother to install the filters that the manufacturer, and they wind up wiping out everybody's RF capability for everything. Those are situations where those have to investigate. But other than that, site surveys are not necessary. Line of sight is not necessary, except for very long distance. There's a lot of flexibility in the architecture. Once again, if I am going to do SIS, I'm going to add wireless HART rather than build it in. I'm not going to spend a lot of time on this slide. For all of these things, training, 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 where would you get it? Well, the very first place to ask is the vendors that you're going to trust. What training do they have available? I'll tell you what, working for a major vendor, I do a lot of these training sessions. Some of them are paid for sessions, some of them are free, but your vendors will fall all over each other trying to give you training and make it easy for you to use their products. So talk to your vendors first. Second thing is, look at the protocols that you're considering using. Do they have standards bodies that are strong behind them? Do they have standard bodies that have established training schools? Look, Foundation Fieldbus and Profibus both have. I just did a Profibus network engineering course at an accredited academy. Look for those sorts of things. Those are available. The tools you can use, some things are protocol specific. I'm going to have a slide coming up at the end of this that shows some of the tools. But protocol specific software, and then there are generalists. This is the only picture that I'm going to show actually. That is a Fluke 225C scope meter. Very, very capable piece of equipment, and it also has diagnostics for every bus you can think of built into it. That's why I showed a picture. It's a wonderful tool with an oscilloscope built into it. So it's just a good diagnostic tool for anything that you would choose. Your support team is going to be, once again, your vendors, your field devices, your physical layer manufacturers, who are not going to be the same as your field device. They're going to be different. So build your support team from them. Get references. When we talk a little bit about the use case that I'm going to go through fairly quickly, you're going to see that he did that very thing. He talked to the people who were using the protocols he was thinking of using. And then the ENC firm, have they done this before? I can't tell you the number of ENC firms that I've been involved with where they were doing it for the first time, and their end user client paid the bill for them to learn. So you want to check that out up front. About the control host, and I'm not advocating. I'm going to show you pictures of 3 of them coming up, but here are the basic ground rules. All of them should be able to use all the protocols that you want to use with equal ease. It should appear seamless to your operators. Your operators should not even have to know where the data is coming from. It's just that they have the data. It should be very, very quickly. The configuration and commissioning should be easily done through the host. Asset management. I can't tell you how strongly I feel about embedded asset management. Going forward, we all have to do more with less. We've been living with this for decades. The fiscal meltdown of the late in 2008 made it worse. Having the ability to talk to the stuff that's running your plant, or better, having the stuff that's running your plant talk back to you without you having to ask it, that only happens if you've embedded asset management. So look for a host that does that naturally. It's not a force fit. It's not an overlay. It's not it's not a last minute, oh yeah, and we can also do this. No, you want it incorporated, and has the best support for your project. Your support, your vendor support around you has the best choice of nodes available, and you may want to use different asset management applications. Once again, they're coalescing. That's a subject for another day. So here's a picture of one. Those of you who recognize logos probably recognize what this is. It's not the way they look today, but it's a pretty good. This object of this slide is all of the various protocol logos that are shown. This host handles them all with equal ease. So does this one. Once again, and so does this one. Now in this corner, down here, we're showing the future. This is Profibus DP with all the protocol, either the direct connected nodes or the protocol converted nodes connected. This is Profinet. There are no protocol converters anymore. They're all proxies. So you have a Profibus PA proxy, you have a HART proxy, you have an FF proxy, you have all of the various DeviceNet proxy. They're all connected on a net, and that net can run 100 to 1,000 megabits per second over a short distance, where the Profibus DP bus can run at 12 megabits per second. It's like watching paint dry compared to this, and that's why this will gradually fade, and this is coming more to the fore. So what does the future hold? Bus-based SIS. Somebody's going to buy serial number 1. FF safety has been proven. ProfiSafe has been proven. Somebody has to buy it. The wireless HART and Foundation Fieldbus and Profibus merging. Both of those standard bodies are working on that right now. The device types in wireless HART are exploding. And then finally, software based on human-centered design to make all of this stuff easy to use is already here. It's on a limited basis, but it's already here. And this is where it's going. This is a very complex instrument to set up. How do I set it up? It's embedded. It's task-based. Those buttons tell you how to do it. You don't have to know. You just follow the steps. But that's what those various screens are portraying. This landing screen, which is called the dashboard, kind of like on your car, but your car dashboard does you the same thing. Just think about it. You're looking at the traffic at 85 miles an hour on the interstate, bad person, you're speeding. But you want to know how fast you're going. You know you can, at just a fraction of a second, look down at your speedometer, look back up. That's why we have a representation of the PV as a gauge, even in the digital instrumentation. But what's the point of this, this dashboard interface? It has been proven for decades of research that's nearly 2/3 of all instrumentation checks were a waste of time and money. They were either a routine PM or somebody didn't know what the offset was, so let's go, you know, it's got to be the instrument, let's go out and check the instrument, let's write a work order, let's go out and check. And 2/3 of the time it turned out to be a waste of time. If I have the knowledge built in and I can do one mouse click and see this, I eliminate 2/3 of my tasks right there, right with that. And it is independent, this human-centered design approach is independent of measurement type, it's independent of protocol type, it's independent of delivery of asset, whether it's EDDL or DTM. It doesn't make any difference. They all look the same. The training is reduced because everything looks the same. It all works the same. The asset managers all work the same. The interfaces work the same. This is making technology that is increasingly complex get increasingly easier and easier to use, and that should be the object. Here is an instance where the device has said, you know what, I'm not good. There's something wrong. So what happened? A button appeared, and when I pushed the button, here was embedded troubleshooting. Think of that concept. I don't have to go find the instruction manual. It's built in graphically. If I've never seen the inside of this device, I know what it looks like now, and there is where my problem probably is. Very briefly, a use case. Very, very interesting use case, actually, in that what this screenshot is from the Orange County Water District. That's what OWCD stands for. Just north of where that arrow is, that wall, that is the Orange County Sanitation District. Guess what they're sending 70 million gallons per day across that fence is? You got it. Because a big problem in Southern California is pumping out the groundwater to water lawns and drink and wherever you're going to use the water for, and then the Pacific Ocean says, oh really? Pressure in the ground is reduced? Ooh, we can fix that. And then your groundwater is poisoned forever. It's salinated forever. So what the good, intelligent folks in Orange County did was, hey, let's take some of our gray water, let's purify it through microfiltration, reverse osmosis, and UV. Let us get us so clean that we actually have to introduce minerals so that we won't strip our pipes. That's how clean they get it. And let's pump it back into the ground to keep the Pacific from encroaching. That's what this process is for. They don't drink this directly. They pump it back into the ground. So what were the design considerations? Selection of, and here's what he selected, Foundation Field Busing Device Net. He had to figure out how to represent his engineering documentation. However, he discovered that he could reduce the number of devices because most of them are multivariables. His electrical design got simpler. He did have to figure out how to separate voltage and signals and segment design, and he got help from lots and lots of people to do this. He also decided to lowly load or lightly load his segments. Remember I talked about once you have the infrastructure in, it's easy to add. If you lightly load your infrastructure, it's easy to add for years, and that's what he decided to do. His construction kit, once again, proper cable tray design. He did have to coordinate between different system integrators. So he had a little work to do. By the way, this project is undergoing a 50% capacity expansion and the lessons learned the first time around, which is what we're looking at on these slides, made his job a lot easier. I'm not going to read the rest of the slide. You can get this on your own and look for it. Why did he choose Foundation Fieldbus? Best choice of field devices. These construction benefits, built-in asset management, and he did do his research. He talked to people who used Foundation Fieldbus. This is kind of why the field devices, no matter what type of field devices they use, have unparalleled diagnostics built into them, not only about the device health, but also about the process, process connections, impulse lines, noise in the process, air entrainment, water entrainment, all of that is available to him. Why did he choose DeviceNet? Flexibility and familiarity. Remember I said earlier you can do discretes and motor control. He likes the Rockwell active front end. He liked his distances fitted. He had lots and lots of use experience with DeviceNet, and because of the different devices he could use, he could learn he could teach his technicians once and use it on many different types of devices, and he could get what he wanted out of the protocol. I'll go through this very quickly. Look, I will just land here. Look at the total number of I/O, and look how much of it is bust. Virtually all of it is bust in some form. And he will never go back to doing this the analog way. He's learned. And people who go all digital do not go backwards, I will tell you that. People who do Foundation Fieldbus control in the field do not take control loops back out of the instruments. They go one way. So here is the wave of the future. We're going all digital for a reason. We all are living with this in our work lives and in our personal lives. We've got more to do and less time to do it. Faster sometimes really is better. In abnormal ASP, abnormal situation prevention, if I have instruments that are so smart that they can tell me that something's about to happen, like I'm running a distillation column at the edge of flooding, because that's the most efficient place to run it, and my instruments can tell me in 3 minutes this column is going to flood. Think about what that's worth to you. First-time adapters have to climb a learning and cost curve, but if you plan up front, you can drive most of this cost out. That's a story for another day, but it's been done successfully, and it's been done in emerging, what do I want to say, parts of the world where automation was not common until the last 10 to 15 years. Where automation projects, this may be the first one they've done in an area, and they're going right to bus. So think about the training that has to take place, but they're making it work. The largest oil refinery ever built is mostly Foundation Fieldbus. This is a slide. You can tell this was a training course, Profibus, Profinet. I just say great protocols think alike almost. The only thing I argue with on this is the stack up of the logos. I would obviously take this one and I would put it closer to the front here. But using the right tool for the job. That's why I said at the beginning of this you're going to use more than one protocol. And this, for anybody who wants to check it out, is Smart Discrete I/O. It's being promulgated in Europe. It's called IO-Link. You might want to check it out. Here are some references that people can follow. If you get the live slides, those are live links. As you can see, my cursor changes to finger. Those are live links. These are all of the standards bodies. But this one is open, and Emerson's Plant Web University. You can either follow the link or Google Plant Web University, and you will get this. They're 10-minute courses that you can take. They're designed to be done start to finish on a coffee break. And there is a ton of information out there that you can go take a look. Where it is commercial, it is highlighted and it's set off to the side in sidebars. For the most part, it is non-commercial. It is as non-marketing oriented as any vendor can possibly make anything. This is from Emerson Exchange. If you come to Emerson Exchange in October, a good idea for those of you who've never been. For those of you who have been, I'm preaching to the choir. But on the trade show floor, and the trade show doesn't open until 4 o'clock in the afternoon, Emerson Exchange is all about the information exchange. It is not about the hardware. But on the hardware portion, all of these vendors were in that room. And the folks that were in this presentation at Emerson Exchange when I did this last fall, I told them, go down and talk to those vendors. They have tools you can use to work with these various protocols. Notice the overlap. Notice that most of them can do most of them. The one that can do the most is Fluke. And then finally, that's me. If you want to contact me, you want to get copies of the slides, you want to call me, that's me. And thank you for joining.